A little bit more on our discussion of modular arithmetic. And what I have drawn right here is a coordinate axis. And let's say the red tick marks correspond to every 10 numbers. So the 0 is an origin. 0, this represents 10, which is, um, and this represents 20. Okay, this represents negative 10, negative 20, and so on down this way. Now, in BASIC, when I do the modular operation, so for example, let's say I do 27 mod 10, what it does is it goes up here to where 27 appears, which might be right about here. And then it keeps subtracting 10 from that until it gets the number which is right in here, which is 7. Another way of thinking of that is it takes 27, it divides by 10, it gets 2 with the remainder 7. So it takes the remainder of the long division, 27 divided by 10. Now what happens for negative numbers? Suppose I had negative 27, which appears right down here. Let me use red for that. No, red, blue. Okay. So suppose I had negative 27, which appears right about here. Okay, well, let's investigate again. Let's write this basic program. And here I'm going to pull it up here. I'm going to do, okay, 10 input x. So we input our variable x. 20, I want to do y equals x mod 10, and then 30, print x comma y. Let's run this, and let me try it. It's asking for x. Let me put in 27 first, 27, and it prints out 27 and 7. So 7 is the right answer for 27 mod 10. Let's run it again. This time let's put in negative 27, and it brings out negative 7. Well, but negative 7 isn't exactly what I want. You see what the program is doing here is that it's taking negative 27 and then bringing it up to negative 17 and then negative 7 right here. And this is the output. But what I want to do is bring it all the way up to here. Now this isn't plus 7. This right here is negative 7 plus 10, or this is, so this point right in here is negative 7 plus 10, which is 3. And this is what I want for doing Caesar cipher. I don't want negative 7, I want 3. So how am I going to get that out of this basic modulo operation? Well, one thing, I can add a statement, for example, that checks to see if y is negative. So I can say, let me add statement 25. Let me pull it here down. Here's our basic program. Let me list it so we can see what I'm working with. Now I'm going to add statement 25. And statement 25 will be if y is less than 0, then y equals y plus 10. Let's give that a try. Run. Okay, put in negative 27. Missing then, oh, I forgot, I misspelled my net, and then it's statement 25. Look at that. 25. If y less than 0, then y equals y plus 10. Now let's run negative 27, and it gives me the right answer. So I have to add that extra statement because I don't want, when I get a negative number, I don't want to bring it up to the interval of 0, negative 10. I want to bring it all the way up here, and I want to do it by keep continuing to add 10 to the number. So I start with negative 27, I add 10 to get negative 17, add 10 to get negative 7, and add 10 to get negative 3. So the modular operation I want is a little bit different than the modular operation that's provided by the basic programming language. So let me look at that program again, and this is the program that gives me what I want. Okay, list. So I have to add this extra statement right in here. If y is less than 0, then y equals y plus 10. So that seems to give me what I want. Now, let me give you an idea of where I'm going here and what I want to try to do with this modular operation. And let me erase all this here. Because what I want to do is I want to look at the alphabet. So I know I have, the alphabet is the letter A, and then B, and then C, and so on, all the way up to Z. And suppose, for example, I call A 0. If I call A 0, then I go all the way up to Z is 25. So that would be the 26th letters in the alphabet, and I number them 0 to 25. Now with Caesar cipher, what I want to do is look at, if I have a message, let's say the message is A, B, C. What Caesar cipher does is it looks at the number corresponding to each letter, okay, and it adds 3 to that number and gives me the letter that corresponds to the new number. So 0 plus 3, which is for the letter A, corresponds to the letter numbered 3, which is D. So A goes to letter D. Why? Because D here is letter number 3. E is letter number 4. And F is letter number 5. So A now goes to letter D. The B, add 1 to, or 3 to that, and it goes up to letter 4. And C, add 3 to that, and it goes up to letter 5. So ABC by Caesar cipher gets turned into DEF. Now, what Caesar does, however, is he'll take a letter up here. Let's say we have the letter Y here. So the letter Y is 24. And when he adds 3 to 24, he counts in this way. 1, 2, 3. So he comes back to the beginning so that Y plus 3, okay, is 24 plus 3. Which is 27. And he wants to wrap that around. So it's like doing modular arithmetic. He wants to take, so we have 26 and then 27 here. He wants to take 27 and bring it around here. So we're doing a 27 and bringing it down to, okay, 1, 2, 3, and wrapping this around to B. So that Y, we want to figure out how to map Y to letter B. And I want to try to use modular arithmetic to help me with that wraparound. Now, one thing I can do, for example, B is the letter 1, notice. B is the letter 1. Now, if I did 27 and then mod 25, that gives me 27 divided by 25, and the remainder is 2. So 2 doesn't give me the letter B, it gives me the letter C. If I did 27 mod 26, which is how many letters there are, then that gives me 26 divided into 27 has a remainder of 1. That gives me the letter B. So with Caesar cipher, to implement this with 26 letters, 0 to 25, what I want to do is I want to add 3, but I want to do it mod 26. Let's see how the program might work to do that. Okay, here's the program that I have right now. Input x, y equals x mod 10. I want to change that to 20, y equals x mod 26. And I'm going to still keep that 25 the way it is, except I now need to write 25 if y is less than 0, then y equals y plus 26. And now let's run. Now I said that the letter y was 24, and it maps using Caesar cipher. It maps to B. It maps to the letter 1. So I want to input 24, but I want to add 3 to it to implement Caesar cipher. So 10, I have to write a statement 15 here. Let me skip this one. Okay, statement 15. Add to one more statement. X equals x plus 3. Let me list this and see what I have. Input x, I add 3 to the letter's number. I compute y equals x mod 26. Check for negative. Now let me print it out. So the letter y is 24. So run, input 24, and indeed I get the number for the letter B. So this is example of how Caesar cipher would work. Now suppose that I wanted to undo Caesar cipher, and I had the letter B, and I wanted to find out what letter it maps to. So I have the letter 1. But now what I want to change here is I want to change 15 to undo Caesar cipher. Let's say to decode Caesar cipher. I'm going to write x equals x minus 3. Now list. Now let me try this and see if this undoes Caesar cipher. Run. Put in the letter 1. Okay, it gives me 8, the letter 8. Now, so that's not doing exactly what I want. So I have to figure out a way to undo Caesar cipher to bring me back up to 20 to work this out properly. Now, okay, here's what's wrong. See that? I have plus 10 here. 25, statement 25 is wrong. I wrote that wrong. If y is less than 0, then y equals y plus 26. Now list. Now let me try that 1 and negative 3. So run. So I want to reverse the y. I put in 1, and now it gives me 24. So I had that mistake in the program right there. So you can see the run forward on Caesar cipher, we want to put a plus 3, and to reverse Caesar cipher, we want to put a negative 3. So, some more on Caesar cipher in the next video.